Kia ora and good morning or good afternoon, depending on which part of the world you might be in, and welcome to the second of the Beca and SpaceBase monthly webinars focused on space and the information domain within the New Zealand context. Many of those may already know me. I'm Brendan Pett. I'm the Ops Manager for our Trans-Tasman Defence and National Security business and also the Beca lead for space. Look, thanks for taking time out today to join us and our partner SpaceBase as we continue to look to use this series of webinars to help inform, educate, and importantly, connect us all across the various parts of the national space ecosystem. It's our joint hope that through this series of webinars, we're able to help support and grow both the national space capability as well as our ability as a country to then contribute to the wider international space effort. Following on from last month's presentations by the New Zealand Space Agency and SpaceBase, today we have the New Zealand Space Institute and Aerospace Christchurch. So I'd like to introduce you to my colleague, Jess Tucker. Jess has over 20 years of experience in the aerospace domain, including support to the US defence and civilian space programs. And Jess will again be your host for today's session. So over to you, Jess.
Thanks, Brendan. So if this is for many of our attendees, this may be one of the first Zoom style webinars that you've engaged in. At the bottom of your screen, there's a panel where you'll find the chat screen and also the Q&A session, the Q&A panel. The Q&A panel is where you can, we encourage and ask that you type in questions and comments for our speakers to respond to using that panel. So that we can make sure that we capture what it is that the audience is thinking about after they hear from our speakers today. So we've got, this is, as Brendan mentioned, the second in a series of webinars where we'll hear from the Space Institute at the University of Auckland and also Aerospace Christchurch to further set the scene for space here in New Zealand. Our first speaker, Professor Aliati of the Space Institute, will provide insight into the Institute's research and educational activities in the space sector. Following, Roland Sommer of Aerospace Christchurch will provide an overview of their efforts and focus from an industry and space sector viewpoint. So without further ado, Professor G Aliati is a leading expert in space engineering. His career started in industry, working on the Columbus module of the International Space Station. He then worked at the European Space Agency and subsequently moved to the UK, where his work spanned academic and teaching, from academic and teaching to consulting for industry. After being awarded the Royal Academy of Engineering Research Chair in Space Engineering, he became the director of the Surrey Space Centre, where he led pioneering missions for technology demonstrations, including active removal of space debris. Currently, Professor Aliati is the director of the Space Institute, Te Pūnaha Atea, at the University of Auckland. Please welcome Professor Aliati.
Thank you for your very kind introduction. Okay, then essentially the Space Institute was formally established in 2019 across the faculties of science and engineering. And the purpose of the Institute is really the creation and dissemination of knowledge to help the growth of the space sector. So essentially, creation and dissemination of knowledge are research and teaching, as we are operating, within, an academic establishment within the University of Auckland. And we are then articulating a series of different activities, as you can see in this, in this slide. So very quickly, I will talk to you about all these things that we are doing. And the starting point was really the academic work, if you want, because when I arrived here just over 2 years ago, I noticed that although the University of Auckland was a big university and there are other big universities in the country, nowhere there were courses that were really dealing with space or aerospace engineering, a proper program and proper courses to deal with these kind of disciplines. And at the same time, my first discussions with companies here in New Zealand, from Rocket Lab to smaller entities and so on, that everybody was crying out to having the difficulties of employing people and having to employ people from abroad, because here we didn't have a local pool of people that could be hired by this company. So these things came together, and the first thing was really to set up some specialist courses that cover some of the key areas of the space engineering, from the structures then to the system engineering and so on. And we set up a master course that now is well, next month we will start for with our second cohort. So we have been already operating, for 1 year. And in parallel to set up these educational activities, clearly our research has been growing. When I arrived, there were already colleagues here at the University of Auckland that were carrying out research activities in various topics within space engineering, space propulsions, telecommunications, and so on. We, with my colleagues, when we joined, we added further research topics, structures, mechanisms, mission operations. And in particular, we are now concentrating, we have a large research group that is really dealing with space situational awareness. Probably most of you are aware that, there starts to be a problem of, let's say like space traffic. We have put in orbit a lot of satellites, and it's a great thing because they are doing a lot of useful things, but at the same time, there is a little bit of a congestion. During the introduction was also alluded that I did some work on the active debris removal because, again, it's a growing problem. And so what we are trying to do here is do some steps forward in various directions. For example, with the orbiting of all the satellites, having devices on board satellites that can help, the orbiting within the appropriate, guidelines, but also in the area of space traffic management, improving our knowledge of where all the various objects in space are, probability of collisions. There is a lot of work that can be done there to ensure the sustainability of the space, of the orbits, and ultimately satellites and space environment. But apart from, let's say, like the academic work, the other activities that we have really started to develop are really everything that underpins an end-to-end capability that we are establishing to set up missions and space hardware from concept to development of the hardware, testing, in-orbit demonstration, and then to help our partner companies and so on to actually exploit these technologies. Okay, and to be able to do this path from the concept to the in-orbit demonstrations, there are certain things that are necessary, certain facilities that have to be established. And so, for example, the first group of facilities under the prototyping, and you have to be able to put together hardware, and you need appropriate lab, clean room. So this has been one of the first areas of focus, because we want, although we work, in a university, and typically universities concentrate on, theoretical stuff, but we really want also to be able to do the, the nitty-gritty, all the real hardware. So I have then a couple of slides that go more into the details of these things. But so prototyping was the first thing, to develop the hardware, and then assembly. Then there is the testing. Before we launch anything in space, it's crucial that this thing has been really tested appropriately to establish if the particular item is able to withstand the launch environment, for example, from the point of view of the vibrations. Then once the item is in space, is it able to survive, vacuum, all the thermal cycling? So we set up this type of facility, not just for our internal, use for our research activities, our development, and also our teaching, but also as a national asset. That's why we call it, Satellite National Test Facility, because we want to host, companies that might have to test their particular hardware. It wouldn't make sense for every single, startup little company to set up their own test facility, because let's be honest, the cost to set up these kind of facilities is significant. And some of these companies might need to do tests for, let's say, 1 week, 2 weeks a year. So it wouldn't make sense to have several of these scattered around the country. It makes much more sense to have, somewhere a facility where, the various people, again, companies, institutions can come and test their hardware. So we are, a neutral establishment that we are happy to support, any company or institution to come here and again, do the testing that they need to be done. And then the other area is really the operations, because very often we focus on, the space technologies, the space segments, but ultimately things have to be operated properly in space to then gather the fruit of what you have been doing. So we also established a mission operation center, and at the moment we are also setting up the antennas, ground stations, and so on. For the moment, we have set up the control room, and we also won the contract for the operation of MethaneSat. Rocket Lab will initially set up all the protocols for the control of the satellite and the operation, and then all this will be transferred to the University of Auckland. that will run the operations for all the duration of the mission. That could be 5-7 years. And this mission is about, again, monitoring methane emission, in particular from the oil and gas industry, but for New Zealand is also important, actually, the emissions from agriculture. And so there is a group of scientists that will work on these kind of areas, but again, not within the center. We will operate the satellite and then pass the data to the other entities that will do the kind of really the processing of the data. And finally, what is also really important is to bring all these things together. And actually, also this this seminar today, and thanks again to the organizer, is part of this. There are a lot of companies, a lot of institutions that work in this area, and we all have to help and bringing all the parts sort of together. Because let's face it, now within the space sector, all the projects are partnerships between different institutions. It is very rare that within a single place, a single company, you can really contain the whole thing. So this the partnership is an important aspect, and in particular for us, what we want to do is let's say really enable then the exploitation from companies and so on, but we won't do that ourselves, as we are again sort of a university establishment, but we want to support that. And so it's important for us to have very good links and relations with the people that then do, I don't know, the post-processing of the data, or really the utilization, so that our work has a positive impact on communities and so on. And before we had the last big wave of COVID, we also organized together with Auckland Unlimited one of these events where we had about, I don't know, 150 participants or something around the area of Auckland, to try to again bring people together so everybody is aware of what everybody else is doing. And again, so if I can get to the next slide, yeah. So as you can see from this slide, this is quite a busy landscape, I would say. The sector. We are, as I said, within the University of Auckland, but we work with a lot of other bits of the university. For example, again, talking about hardware, we want to put together, again, things that have got structures, electronics, and so on. So we work with all those departments, but also with, for example, in science, with the School of the Environment, because, for example, now we are trying to push for a mission to monitor, the quality of water, because we know for New Zealand is an important thing. So for us to work with the people that are really at the coal face is very important, with uni services and so on. So we operate with all these other entities, but what we bring to the general party and to the sector and all these companies and institutions that are on the right hand side, what we would like to offer is expert advice on the areas in which we have really key expertise. Because as I mentioned before, there are a lot of new entities or established companies that maybe they have to tackle a particular type of issue, a particular problem, but doesn't make sense for them to actually have that kind of knowledge in-house and set up, a whole department or a person that deal with that kind of problem, where maybe what they need is just some, let's say, like consultancy work to sort out an issue and then move on. So we would like to do this, provide this sort of function. Applied research, okay, so again, we are not really a place where we do the blue sky research. That's a great thing, and I'm all for universities doing that kind of blue sky research. But we try to work more, if you want, practical things, try to answer real questions and again develop then applications where we can see a practical usefulness, a route to market. And so we tend to focus on these, on the technology development. For all of those that are familiar with, the TRL level, technology readiness level, we operate sort of like in the middle, okay, where, the first principles, the scientific base has sort of been established, but you are not yet ready for, the industrial implementation. And so you need to prove that actually the basic concept can be, I use the word engineered, but let's say can be put together in a way that it really works. So we operate in this middle sort of area, the middle TRL, and then we are happy that our partners, companies, and so on can do the exploitation of the technology and actually have the profit and whatever, with our, with the support that we can provide. And again, as I briefly mentioned before, also what we would bring to the party is these technical facilities that I mentioned before, for covering all the various, key areas, because again, there is no need for every single company or institution to have these facilities, which otherwise would be really underutilized. And then to conclude, also the other two important things that I mentioned as I started is talent pool, the fact that it's necessary for us to, if we want, the sector to grow, we need to have an appropriate workforce that is ready to be hired, candidates that can be hired by these companies. So we believe that our students that have done, our program and our courses will be, better candidates maybe to be hired by the various companies, the various institutions that work, within the sector. And also we hope that some of the ideas, the things we are working with, and maybe where the ideas came within the university via PhD students and so on, can become, spin-offs and companies that tomorrow will be, the new, maybe Rocket Lab, the new big companies that there are in New Zealand. So looking a bit more into the details of the various, the three type of facilities that we are putting together. The first one I mentioned is this, the labs for, let's say, prototyping the idea. So we have set up a big lab, 165 square meters. So it's this very large room where there are different areas, some for, the last final minutes, mechanical type of adjustments or electronic type of things, because we are not really manufacturing the stuff, within the institute. We will buy, source the various things, but here is where we do the assembly, the integration, the testing, that all the various subsystems and all the various parts, talk to each other, that the whole thing sort of works. And with, once we are happy that things are working as they should, we have an area, again, our proper clean room, 40 square meters. So is a reasonable size of clean room where, again, we can finally put together the hardware, really then to be tested and launched and operated in space. And we have sized our clean room in a way that we can work, for example, simultaneously on two large CubeSats or on a single larger, microsat up to, let's say, like the 50 kilo. But again, the space is quite modular and is, again, big enough so we can use that space ourselves with our students for our, R&D. But at the same time, we believe that there will always be space for our partners and the company that maybe they don't have a clean room, but they need to assemble something in a clean room. They can come and work with us. And again, we would be happy to host them, almost if we were a bit like a technical incubator, where companies can come and have that kind of support. Small enterprises, small, startups and so on, can have that kind of technical support, because typically, incubator give the support of, all the administrative side and so on, but we want to support them, from a very technical point of view. The other thing that I mentioned, the environmental test facility, this national satellite test facility, this should host, the typical equipment, for vibration testing, thermal vacuum. And the way we have sized our equipment is, again, we want to be able to go up to something that is, 50 kilos, half a meter by half a meter by half a meter. So the idea for this, sort of size is that throughout all our discussions and our experience, it seems that there is really a sweet spot for the size of satellites, which is not really the CubeSats, because although they are good for certain things, they are really too small to deliver, proper services. So we think that this, there is a soft spot at about, 30, 40 kilos, where you can have something that you can still handle within a relatively small organization, but still have outputs that are meaningful and useful from a commercial point of view. And as I mentioned, all these equipment will be, again, state of the art. For example, in terms of vibrations, we will have a new type of shaker that can simultaneously vibrate, X, Y, and Z, which is really much better than the normal thing that you have in a typical test facility where you test only along one axis at the time. We will have that as well, because it's important that we tick, the boxes that the tests have to be done a certain way. But we also want to be able to push forward with, with the state of the art. And the other area that I mentioned is the Mission Operations Center. So the picture that you see there in the center is really the, let's say, like the room, the Operations Center. And from here, connecting with our own antennas that we are currently setting up, but also linking with networks of other ground stations around the globe. We want to be able to again control our own missions, our own satellites, download the data, and then again use the data. And this room you see on the pictures on the right, the configuration can actually be changed, and there is a partition in the middle of the room because you might want to have some sort of segregation for more secure activities. You know, there are certain things where you are happy to have the room open up because, for example, you want to use it for a lecture, you want to show students how you really run, you know, space operations, not just in a book looking at the link budget. You want really to show them in real time, this is how you send the commands, this is what you get in return, and so on. But there will be other time when you want, you know, you might have a commercial customer or someone, so you want to close off the area and you want to be able to run your, you know, operation in a much more secure sort of fashion. And so we have, you know, 4 different areas with, you know, different levels of security to cater again for the different needs. And our idea that again, all these facilities are really multifunctional. So can serve an educational purpose, can serve a research and development purpose, but can also serve a support purpose for other companies and institutions that want to take advantage of what we can offer. And my last slide is really the sort of like the big picture, our roadmap. And initially, when I arrived, the master plan was to do all this in 4 years, and the COVID clearly has not really helped. And so, you know, the whole thing is a bit stretched, which is not uncommon in any, you know, space business. I would say in any business, you know, the schedule tend to really expand all the time. But we are almost done with the first phase, that is really establishing ourselves and the various facilities that I mentioned before. We have set up our master courses in aerospace engineering. We had our first cohort. So in a few weeks, we will have our second cohort to come in. Now we are in this phase, sort of like in the middle, where we are again finishing off the establishment of the facilities, but really starting all these partnerships with institutions, companies, and so on to actually work together. For us, the first step was really to, you know, establish ourselves, because otherwise you do not have anything that you can bring, you know, to the party. So first we had to, you know, develop our offer and making sure that we could actually do something, you know, practical to engage and have something to offer. So done this, now we are really trying to operate in this sort of partnerships with various companies. We have a series of research projects going on. Some were already going on when I arrived, like electric propulsions. We have started our more projects on satellite actuator, mission analysis. There is a variety of research activities, research projects going on. We would like to see most of them, or those for which is appropriate, to really converge to an in-orbit demonstration. Because in our business, if you are able to demonstrate your technology in space, you really can jump ahead all the competition and really leapfrog your competitors. And so this is what we really would like to do, to be able to support the capability to develop the hardware, do the in-orbit demonstration, and then enable the commercial applications, the exploitation of the data, and all to help, you know, really the growth of the ecosystem that is already established, but clearly, you know, needs to grow further to be, you know, more sustainable and also compete better on the, you know, international. And so with this, I think I gave you a reasonable overview of, you know, what the Space Institute is about. And if there are any questions, I'll be happy to answer later.
Thank you very much. We would still like to invite people to attendees to submit questions via the Q&A panel that's down below. This is a way for you to ask questions. Our speakers will flag them as either to be answered live, or they have an opportunity to provide a written response, right, that all of our attendees should be able to see. So our next speaker, Roland Sommer, is a founder member and current committee member of Aerospace Christchurch. Following time in the UK Merchant Navy as a radio electronics officer, Roland joined Tate Electronics in New Zealand as in a manufacturing support role. He later ran, he later set up and ran the test engineer department at SwitchTech, ultimately becoming general manager for the systems division. A passionate advocate for technology manufacturing, Roland sits on the manufacturing advisory board for the CECC. Roland recently left his general manager position at TE Connectivity and is now setting up his own consulting company, Andromeda Consulting Services. He has an HNC in radio and radar, an HND in electronics, an MBA, and is PMP accredited. Please welcome Roland Sommer.
Thank you for that intro, Jess, and good afternoon, everybody. Okay, this afternoon, what I'm going to go through is an introduction on Aerospace Christchurch, who we are, what we do, and where we fit. And it was really good, Professor Aliati, to hear your presentation, because we've got some great harmonies between what we're trying to do in Christchurch and what you're doing in Auckland, as we've discussed before. So I'm going to go through our vision, mission, purpose, and values to begin with. So our mission is to create an internationally acclaimed business hub that exceeds 50 million annual revenue by 2030. And our vision is by 2030, Spaceport Christchurch will be a major Southern Hemisphere gateway to space. Okay, our values and purpose. Our values are connecting people. If it's worth doing well, and give respect and get respect. And the purpose of Aerospace Christchurch is to develop a world-class Canterbury space industry cluster that incorporates industry, education, and local government. And that's quite important. It's broad, it's industry, education, and local government. We want it to be a unified aerospace organisation that encourages business development, encapsulated in our tagline, making space for business. So the team, this is the team. There'll be a few familiar faces in there, but our office bearers, Mark Rocket from Kia Aerospace is our chairperson, Michael Reid from SkyBase is our secretary, and Mark Patton from Ernst & Young is our treasurer. And also a mention for Vicky and Emily, who are our two employees. So our core activities for developing and marketing aerospace businesses to establish Christchurch as an internationally recognised city of new space. What we're trying to do, what we do, is sharing the vision. And there's things like interviews, these podcasts, pestering politicians at every opportunity, just getting it out there that there is a story around aerospace in Christchurch, and it's a good story. I'm going to talk about our space strategy shortly, so I won't go into that now. Connecting our highly successful meetups to foster local collaboration and information sharing. And the interesting thing about these is that the last one I went to, some of the conversations that were happening there, it was a lot broader than your propulsion systems, your CubeSats, your drones. There were conversations about plasma igniters, healthy home solutions, green hydrogen. So there's a lot of other conversations, a lot broader conversations than one may first think of that occur at our meetups. And to support various incentives, such as the Space Challenge, and we do have an aspiration to develop a $1 million space prize. That's an aspiration at the moment. So how we started. The genesis of Aerospace Christchurch, it evolved after a call to action by Jill Daldin of Christchurch NZ, after Miranda Satterthwaite's talk on extreme environments at Tech Week 2018. And first meetup we had was in July 2018, so a few months later, and that was instigated by Mark Rocket and Raphael Cargrin, along with Jill Daldin, who was a key driver and assisted us in getting a venue for that. And our first meetup, we had about 70 people. which was far more than we originally expected. And it grew very quickly from there. This slide here, this photograph, this was from July 2019, so a year later. It was the 50th anniversary of the moon landing, and we had about 250 people there. So it built very, very quickly. We hold these about every 6 weeks, and before we had restrictions, we were always over the 200 mark, and now we normally get at least 100 in person and well over another 100 online. So we've also held various brainstorming sessions. This was one on CubeSat applications. There'll be a few familiar faces or backs of heads in there. And more recently, we've also held a mentoring program that was really successful. And of course, other initiatives such as the Aerospace Summit. And that is now rescheduled for the 3rd time, and 5th of September is the new date. So I want to spend a bit of time talking about the Deloitte sector report and the Christchurch strategy from Deloitte. So this was very kindly sponsored by the MB and New Zealand Space Agency, I believe. And I think on the last podcast, Eric and Emmeline went through this in a little bit more detail. The main thing that came out of it was the size of the aerospace industry in New Zealand at 1.69 billion. And this really was an inflection point for the industry because it made the broader central government and other politicians sit up and take notice of the industry because of the size. So MB and New Zealand Space Agency also very kindly sponsored the Christchurch sector plan. And I'm going to talk about this in more detail. But first of all, I want to build on some comments that Eric and Emmeline made in the last podcast about why Christchurch. They put it very, very succinctly, and I just wanted to build with a few of my own points on that. Christchurch, our size is really one of our big advantages. It's no more than 20 minutes from anywhere in Christchurch into the CBD. And that means things like our meetups are a lot easier to hold in Christchurch than they would be in Auckland or Wellington, because it's very quick to get there. We're also very strong with our tertiaries, University of Canterbury and Ara, but also, as highlighted in one of Eric and Emmeline's slides in the last podcast, Christchurch punches very much above its weight in manufacturing. Also, what we've got in Christchurch is a very solid base of engineering R&D. Now, apart from Tate as a local company, that's always been the mothership in Christchurch, Tate Electronics, or Tate Communications as they are now, but also we've got multinationals that have got engineering centres specifically in Christchurch, and that includes Trimble, Invacare, that used to be Dynamic Controls, Enphase, Allied Telesis, and Johnson Controls. And these are global engineering centres that are centred in Christchurch. So moving on to what we want to play with becoming a globally distinctive centre for aerospace. The two key areas in that is the application of aerospace data, and already companies like Sequent, Orbica, and soon Kia, and further down in the South Island Sierra, we've already got a momentum building there around the use of aerospace data. The second point, a world-recognised test site for emerging aerospace. Again, Eric and Emmeline went through this on their last podcast, but still building on that, or some of the key points, our clear skies, our supportive regulatory environment, our areas of low population density, our access to local technical expertise, That gives us a compelling differentiator to almost anywhere else in the world. And I'm going to build on that in the next few slides. So other things that we are doing for test site, the government has already made a significant investment in Project Tawhaki on the aerial test. And also Aerospace Christchurch, we have an ongoing project for a UAV test site in the red zone. And that is our first foray as an organisation into physical infrastructure. So, and the other place we want to play, the self-contained aerospace ecosystem, that is quite specific. We've got hardware design, manufacturing, launch, and data capabilities. So again, bringing in that manufacturing and the hardware design into play. Christchurch has got 4 supernodes. This is from our local economic development agency, Christchurch NZ. Of those supernodes, aerospace and future transport is one of them. And what we have done through Aerospace Christchurch in conjunction with Christchurch NZ is we've integrated the relevant recommendations of the Deloitte sector plan with the aims of the supernode, and we've developed a concept that's currently called the Andromeda Aerospace and Future Transport Hub. So it's basically an innovation accelerator similar to Outset Ventures or Level 2 in Auckland, but with a very strong emphasis on the physical side of hardware development. Now, this ties in very strongly with Professor Aliati's presentation before. Now, what this does for Christchurch provides the linking mechanisms, the infrastructure and cohesion between hardware, and I say hardware ideation and hardware commercialization, whilst drawing on existing business accelerator infrastructure. Things like regulatory compliance assistance, prototyping, bench and aerial testing, access to commercial manufacturing capabilities, all under one roof, or access to it coordinated from under one roof. So it'll contain the infrastructure or have access to the infrastructure needed to take a hardware project from ideation through proof of concept and prototype to scale manufacture, plus support when the product outgrows the hub and requires a separate manufacturing location. Now, why do we want to do this? And probably this is very similar to Professor Aliati and what the Auckland Space Institute is doing. But I just wanted to talk a little bit more about building on the compelling differentiator that we have in New Zealand with our frequent and easy access to space, which means that we can put stuff up very easy to test. Or I shouldn't say very cost effectively and frequently to test. So if we're able to compress that test cycle by getting stuff up into test, if we've got a very slick and coordinated system to be able to shorten the ideation to commercialization path, then we've got an unparalleled first mover advantage here in New Zealand. And that's why we've got this focus on, or one of our focuses being on the hardware manufacture side. And as Professor Aliati said, the barriers to entry around hardware are quite great. For software, a computer, bit of processing power. For hardware, you need surface mount line, you need access to 3D printing capabilities, you need your 1D and your 3D shaker tables, all of those things which we're starting to build together here in New Zealand. Now, this integrates with present infrastructure. We're not trying to duplicate anything that we have. New Zealand is far too small for that. What we want to do is to fill the gaps and coordinate activities with existing capability. So this is showing that we get inputs of ideas that come in from the tertiaries. The present incubators like WNT Ventus, Te Ahaka Level 2 do their bit. And then when it comes to the hardware side, that is where this concept comes in. The business side, there's providers there in Christchurch. ThinkLab is one that will do the business side. Andromeda Aerospace and Future Transport Hub is really just looking at the physical side, a little bit like in Auckland with Professor Aliati. Now, what we want to do is coordinate and collaborate with all the other parties. We want to fill the gaps. We don't want to compete. New Zealand is too small. It's not about empire building. It's about Aerospace Team New Zealand, as we like to call it. We're one country, we're one team, and we want to be able to provide coordination between infrastructure and capability that already exists and fill the gaps. So this concept is lodged as a potential mission priority with MB. We've got all the plans and we're just looking for funding and the right time to do this. Now, a shout out to Eric and Emmeline from SpaceBase for their hard work in the education sector. It was another focus of the Deloitte pan, and they're doing great work there, Eric and Emmeline. And also last Friday, the Space for Planet Earth Challenge, that was just superb. Really enjoyed that. So finally, what does success look like for Aerospace Christchurch? Looks like this. It's our vision. Spaceport Christchurch 2030. That to us will be success. So thank you for listening. Thank you for your time. Hand back over to you, Jess.
Thanks, Roland. So we are taking questions via Q&A panel. I've got at least one for both of you, but we'll go to the Q&A session first. At this point, please don't hesitate. Keep them coming. So we've got a question, I think, G, that you would like to answer, and it's about the pipeline of students that are coming through the Auckland Space Institute. What will the impact on the number of students on the domestic? What will the impact be from the number of students on the domestic space industry? Do you see the number of commercial space startups growing? Growth within the government sector?
Yeah, thanks for the question. Yes, I think firstly, I would say that, again, there is already a significant space and aerospace sector in New Zealand that perhaps wasn't very loud, but there are a lot of companies, because one of the discussions I had, again, at the beginning when I arrived, and they say, how is that there isn't already a course in, I don't know, aerospace engineering? And I was told, oh, but we really don't have an aerospace industry, so it doesn't make sense to educate students that then will go and work abroad. Well, I would like to say first that actually there are many companies that work in this sector and they would absorb most of these graduates, but there are also a lot of other companies that perhaps don't build aircraft or satellites or part of them, but operate them, even airlines. And therefore it is necessary to educate and have an appropriate number of people with that kind of knowledge, because even if we are never, let's say that we would never build aircraft or spacecraft, we will still operate them, because now, in this world, you have to operate aircraft, spacecraft, and so on. So that kind of knowledge will be useful anyway, even if the country doesn't really have a big manufacturing part in again, aircraft and spacecraft. And I hope that this won't be the case, because I hope that we will be very successful, especially again in the South Island, with what Roland was saying. But again, so to me, that's necessary. What we teach are also a lot of transferable skills. Actually, maybe I shouldn't say that, but some of our best students ended up working in banking and in the stock market, because they were making much more money than in the space sector. But let's leave that for aside. What we teach are really things that can be applied to a lot of different sectors. But yes, we have to operate in partnerships with government, because some of the, let's say, the funding that is necessary, the things that have to be done, is difficult to see everything just coming up from funding from venture capitalists and things like that. I think that it is necessary to have a little bit of an intervention, let's say, like from central government, to help and unlock all this potential with funding for new enterprises, startups and that kind of things. And then all this will blossom into things that eventually are, commercially viable on their own. But at the beginning, you really need a little bit of support, central support to get all these things off the ground. And this was the case everywhere else in the world. Everywhere I have seen a successful, space cluster or aerospace cluster and so on, there was some intervention from government that then also helped to harness private capitalists and other sources, and the whole thing blossomed.
Thank you. There's a follow-on sort of or related question about whether there is a need for having not just an academic program aimed at students, but something maybe more tightly focused aimed at professionals who are interested in transitioning their skills from a related industry or potentially not related industry, you never know what space can use, into a space-facing sort of domain.
Yeah, if you're asking me, yes, of course, you need a lot of different level of skills, but also, the master, for example, that we have set up is actually to help not retrain, but to take people that have got maybe degrees in more generic disciplines like, mechanical engineering, electronic engineering, things like that, and give those specific areas of knowledge that are really relevant for the space sector. So of course, this, bringing in people from other sectors is an important thing. Also here in Auckland, even before I arrived, there was already operating the APSS Auckland program for space systems, where students from all different parts of the universities, even, law, not just, engineering and science, could actually work together, because for the success of the whole enterprise and the sector, you don't need just the, the scientists, the engineers and so on, but you need, everyone. You need this sort of ecosystem, and you need these different talents to bring together.
That's right. That's right. So on that same theme of related and adjacent domains working together to advance space in New Zealand, question for Roland. In your talk, you indicated that Christchurch punches above its weight when it comes to manufacturing. Can you comment further on the space-related and maybe space-adjacent manufacturing that you're seeing in the region?
Yes, I can, Jess. It does become difficult because a lot of the manufacturers are under NDA, so I have to be careful of what I say. But Christchurch, I believe, have got over 23 manufacturers currently manufacturing for other New Zealand aerospace companies, significant ones. Also in Christchurch, the other one, which it's 3 levels down on their website, and I keep pushing them to make this a bit more visible. But local company AF Cryo or Fabrum Solutions, they've got parts that they have supplied for the Mars rovers. So for Christchurch to have bits that have been built in Christchurch on Mars supporting missions is a pretty big and compelling story. And now AF Cryo are also now working in the green hydrogen space, and they're a leading company in New Zealand around green hydrogen and supplying it up to Auckland, as well as overseas. So a lot happening there. We've also got a lot of very specialist mechanical manufacturing places like Shamrock. That's one that I can mention. And with some of the projects, like out of the University of Canterbury, Sarah Kessen's project with the protein or CubeSat, that has been really good at catalysing or demonstrating some of the capability we've got in Christchurch, because a lot of companies didn't realise they could, what they were doing, which they've done for aerospace, but normally the defence side or the air side of aerospace hadn't realised that they could also do this for the space side of aerospace as well.
Thank you. I've got one more question myself that really I think is for both G and Roland. G, you talked about the test facility and the unique sort of spacecraft or space-oriented testing that needs to happen on space systems, CubeSats, et cetera. And Roland, you talked about the focus on hardware and manufacturing and the need for getting that right. But what about software? Software for space systems is it in some ways, yeah, all you need is a computer and a screen and a keyboard. But there's also there are, especially if you've got stringent safety assurance or mission assurance requirements, there's a heck of a lot of additional process that is layered on top. Are either of you in a position to sort of comment about space software?
I couldn't agree more with what you are saying. And in a lot of cases, also if you look at aerospace degrees in Europe, in the most reputable universities, they are a bit like the situation was 20 years ago, where a lot of stuff was about the aerodynamics, the structures, the propulsion. And I was talking with the guys, in Airbus recently. Say, if you look at our offices now, those kind of groups have shrunk in the last 20 years, and now it's all about the software and so on. And I think that in a lot of cases, the traditional universities have struggled to keep the pace with what was really going on and the importance of the software and so on. So we are clearly trying to address also that, and a lot of our research activities also of the on the space situational awareness and so on. There is a lot of computational things going on, and all the kind of issues that you are mentioning about the importance of the software. But yes, you really it's a typical problem, let's say, of let's say, like, especially on the education side, that we have been a bit slow to adapt to what the new reality really is. And still there are a lot of the traditional degrees that look like, they were, again, designed and probably put together 20, 30 years ago, but things now have moved on.
Yeah.
Roland, yeah, if you, sorry, I took the...
Okay, my turn now, Jess?
Yes, please.
Okay, now I might be a little bit controversial on this one. First of all, software, it's a very big market. It's a discipline in itself, and it's something that can be done anywhere in the world. And I'm not saying we shouldn't do this. New Zealand has got a great software industry. I've been involved in hardware, and I've seen the decline in hardware. And Electronics South, that I used to be chairman of, disappeared, and the software cluster came up, and now we've got the Canterbury Tech that's predominantly software. Huge industry. However, we do not have a differentiator in New Zealand, apart from some expertise. And that is why my focus, and I'll say my focus, because we've got a much broader focus with Aerospace Christchurch, but my focus and my passion has been around the hardware for the reasons I gave in my presentation. We have a strong differentiator in New Zealand around our access to space and around our supportive regulatory environment that nobody else has, and we can commercialize and monetize that. So that's one of our focuses, because otherwise, with software, anybody in the world can do that. We can be better, but you'll never have something behind you that is a differentiator. Now, I'll look back. I'm sure some people here are familiar with Sir Paul Callaghan's address at New Zealand Strategy 2010, when he talked about New Zealand needing to concentrate on niches and weird stuff. And I think with the software side, if you can find a niche that's too small for anybody else to be interested in, but big enough for New Zealand, then you've got a good business case. So my thoughts on that one, Jess.
Thank you. Thank you for that. I think we're at a point where we should probably start wrapping it up. So first and foremost, thank you, G, and thank you, Roland, for your sharing your insights and thoughts with us today. And thank you to our audience for your time and attention. Our next webinar will be in March. I think the specific date is, I can't remember it off the top of my head. My notes don't include it. But if you've attended this one, you'll be on the mailing list for the announcement of the next one. This slide shows the contact information for both of our speakers today. Please feel free to reach out to either of them with follow-up questions or comments, feedback, thoughts. At the bottom of the page, you can also see contact information for the Beca Space and Information Domain webinar series. We would very much like to hear from you as audience members about the value that you're getting out of this. And what sorts of questions and speakers you'd like to see next. So in March, we'll hear from Orbica and Plant Tech, two New Zealand companies leveraging and analyzing information from the space domain to improve outcomes in a variety of applications. The announcements for this will come out via social media, as the announcement for this one did. And again, if you've got comments or questions or feedbacks or thoughts, whatever, we'd love to hear from you. So thank you very much. You can also find us all on LinkedIn. And I look forward to seeing and hearing you all in a month's time. March 23rd. Put it on your calendars. Thanks, everybody.